Hi students, this is Mr. Yao. Today we're going to talk about 2.2 where we'll learn how to simplify rational exponents. So let's start with some vocab. This is something we have seen many times. It's a root, but we have some special vocab for it. This top left number is actually called the index. The x inside the root, that is called the radicand. This whole thing is actually called radicals. We have index, radicand, or base, then this squiggly line is actually called the radical sign. When we read it as nth root of x. So let's say n is actually 4, that's called fourth root of x. If there's no index number, that means no n, there's no number there, it is actually a 2. We have seen that many times, it's square root. Now let's look at example 1. We'll also learn how to type it into our calculator. So we start with math, and then click number 5, click left arrow to actually get the cursor inside the answer part. We're going to clear it, then type in 4, move the arrow to the right, inside the radical sign, then we type in 625. Click enter, that's going to give us the answer as 5. Now we're going to look at the one on the right. So we're going to still type it, click math, then 5, move our arrow to the left, clear, change into a 3, then we can type into negative 512. Press enter, that gives us the answer as negative 8. Okay, now let's move on. We can write radicals as rational exponents. Make sure you actually understand what the difference is. So remember, rational exponents are written as fractions. The rule with symbols. So we start with this radical nth root of x. When we want to rewrite it as rational, we're going to keep the x, the base is still there. But for the exponent, we have this n, we're actually going to write it as 1 over n. And here's the reason why these two are the same. So let's say we have cube root of x. In order to make an x, since it's cube root, that means I need to repeat it 3 times to get rid of it. So I'm going to have 3 times of cube root. That's one of them, that's 2 of them, that's 3 of them. So I have cube root of x to the 3rd power. They would actually cancel. And that only leaves me with an x. In 2.1, we just learned how to work with power rules or how to work with different exponents. So I actually have x to the 1/3 power. I times another x to the 1/3, then times another 1. Since they are the same base, I can just add the exponents. So I have 1/3 plus 1/3 plus 1/3. That actually gives the x to the 1st power, which is also x. Since our final answer is the same and we repeat it 3 times, that means these two must be the same. Now let's look at some special case. What if the index is actually 0? What that means is it's going to be 0 root. So that means we have this. Okay, would that actually change anything? If it's actually raised to the 0 power, it never changes. So that actually doesn't work. We can use the same rule to write rational exponents as radicals. Now let's use some examples to practice. Example 3. We're going to rewrite and then evaluate. So first, I see this 729 as the base, so I'm just going to write that number down. Next, I see this index is a 6, so I'm going to put it as 1 over 6, the reciprocal. That's how I actually use the index. After that, now it's time to actually type in our calculator. So I type in 729. When I want to raise to a certain power, I will use this little cap to get to the exponent part. And I type parenthesis 1 over 6. Parenthesis back, press enter. That gives us the answer as 3. Now I'm going to do the other one. Same thing, I'm going to rewrite it first. So I see the base is actually negative 625. But since there's negative signs altogether, I'm going to put it inside parentheses. Next, I see the index is actually a 4. And I'm going to change that into the reciprocal, which is 1 over 4. Now let's type in our calculator. We're going to have parentheses negative 625, parenthesis back, raised to the parenthesis 1 over 4th power. Press enter. We see our calculator actually give us an error message. That actually is correct. The answer to this one is NA. Reason? Because we have this negative sign right there. When negative sign is actually raised to an even power or have an even root, that does not work. Now moving on, example 5. So this time we're going to rewrite the other way. So I see the negative sign is outside, so I'm going to keep it on the outside. And then I see the bottom of the fraction is actually 6. That means it's going to be a 6th root. Next, I see it's 5 and inside the parentheses as the base. That is going to get inside the radical sign. And we're done with that one. Next, I see this 1/3. So that means my index is 3. I write a radical sign. Then I see 7x is all together as the base. That is going to go inside my radical sign. And that is done. Next, let's learn some more difficult cases, or slightly more complicated. What if we actually already have an exponent? So instead of it's 1 over something as the exponent, we have m over n. So here's one way to think about it. This is the same as x to the m times n 1 over n power. Okay, then I can deal with the x over n, x to the n power first. That is there. But as soon as I see, oh, there's a fraction, I'm going to change that bottom of the fraction into an index. So that's one way to think about it. Or here's another way. I can think it as 1 over n times m. That kind of changed the order slightly. I see it's the index, but the base is only just x. So I'm going to have it as nth root of x. But then I see, oh, I still have this m power. We learned when we have a power on the outside, that's basically as a power rule outside the parentheses in the exponent. So that's the second way to write it. Both would work. Now let's see them in action. Example 7. I have the 6 right there. I'm going to change into an index, so 6 index. And I'm going to have everything else inside the root. So it's n to the 5th power. That's one way to think about it. Or I can just choose to deal with that 6. But I'm going to leave that 5 outside because I feel like my base is just n. So I'm going to put n inside the radical sign. But I'm going to leave that 5 completely on the outside. Next, I see this 3. So I'm going to put that as the index. And then I see 7x is actually together. So I need to make sure I still have 7x. Then raised to a certain power, I have 4, so it's to the 4th power. That is one way to write it. Or since the index is actually cube root, so 3, and I still feel like, more precisely, my base is just 7x. So I'm going to put 7x inside the radical sign. But I still have this number 4 left. I'm going to put that 4 on the outside as a power rule. Another example. This time we're going to rewrite as a fraction. So I see, oh, I have this 5 as the index. That is going to be inside the exponent, but on the bottom of the fraction. Then I still have this 3 on the outside. Now that just becomes a power rule that we learned in 2.1. I can just multiply these two. So I got 4 to the 3/5 power. Or if you want to go faster, just move that directly to the bottom of the fraction. Next, see this is cube root, so it's -8, then to the 1/3 power, but I still have this whole thing as to the 2nd power on the outside. Now I'm going to multiply these two exponents, so I got -8 to the 2/3 power. Lastly, we have an application problem. So we have the radius and the surface area is given as 1493. We know pi is 3.14. Let's replace. So r is still there because we're solving for it. The area is 1493. Then we have this 4 times 3.14 on the bottom, but we still have this raised to the 1/2 power. Now, if you type in your calculator 1493 divided by 4 times 3.14, that is going to give you 118.87. We do need to round it into the 1/2 power. And now I'm going to type it into my calculator on the screen on here. So I have 118.87 raised to this 1/2 power. Okay, put enter. That's going to give me my answer as 10.90. Don't forget a unit. It is meter. That is everything for 2.2. Thank you.